Good afternoon, one and all. I, Assistant Professor Ms. Licia Gomes, welcome you all for the national webinar titled Predictive Banking with Artificial Intelligence, organized by the BBA Financial Services Department of Vidya Vikas Mandal, Sri Damodar College of Commerce and Economics, Margam, Goa. Requesting all the participants to kindly turn off your camera and mute your mic till further instructions. Also, post the questions, if any, in the chat box for discussion during the question and answer session. To commence the session, I request our Vice Principal, Dr. Rodney De Silva, to welcome the virtual gathering.
Good afternoon. It is my privilege to welcome all of you all who are gathered with Mr. Hemant Machine Learning. We learn more on this topic, of which we have a very hazy idea. On behalf of Damodar College, my principal, my management, all my teachers and students, sir, we welcome you and we are very eager to hear your presentation. Students, you can post your questions, teachers also, post your questions and try to get as much knowledge as possible on this very upcoming topic. I welcome all of you all once again, and especially our guest speaker today, Mr. Hemant Palivela. Thank you.
Thank you very much, sir, for giving a nice introduction. So, shall I share my screen?
Sir, just a minute. I want to give an introduction.
Sure.
So thank you, sir. I now request Mr. Sean Menendez, student of TY BBA Financial Services, to kindly introduce the resource person, Mr. Hemant Palivela.
Good afternoon, one and all. It is my privilege to introduce the resource person for the national webinar, Sir Hemant Palivela. Sir Hemant Palivela is the head of Artificial Intelligence and Machine Learning at eClerx Services Limited. After spending nearly 7 years working with renowned organizations like NMIMS and Organised Analytics, Sir shifted to Center of Excellence, Digital Analytics Division of eClerx, where he worked on campaign analytics, speech processing, natural language understanding generation, and recommendation systems. Sir Hemant's principal areas of interest with reference to theoretical frame include machine learning optimization, linear algebra, probability theory, and practical frame include drug discovery, insurance analytics, and recommendation systems. He has published more than 35 research papers in international conferences and research journals. His educational qualifications are BE, MTech, and PhD in computer science and engineering. Thank you. Over to you, Ma'am Licia.
Thank you, Sean. I now request the resource person, Mr. Hemant Palivela, to please take over the session.
Thank you very much, ma'am. Just give me a minute. I'll just share my screen.
Okay, sir.
Do let me know if you're able to see my screen.
Yes, sir, we can see the screen.
So it was a really nice introduction. Thank you all. Thank you, ma'am. Thank you, sir. And thank you, members. Uh, Before I start, right, I also have my intern in this session. Her name is Chahat Tandon, and she is a final year engineering student from BIT Davangere, which comes under Vishweshwara Technology University. So today we will be talking about predictive banking with artificial intelligence. Before I start, let me give some brief about what is AI, what is ML, and why do people, have a craze about this artificial intelligence and machine learning. Now, most important objective which any machine learning method or AI implementation outperforms is to predict what will happen in the future. Now, there are a lot of problems that require this concept, like stock market analysis. You want to know the stock market price. Let's say, for example, you want to understand as a company that who is going to buy your product. Let's say you also want to identify that who is going to do fraud in near future, credit card frauds, insurance frauds, and all those things. Similarly, whenever there is some revenue, there is some profit involved, there's a lot of frauds, there are a lot of things that you have to forecast in the near future. Forecast in the sense, you should know that what is going to happen in the near future, right? So with this context, I would take further and give you a brief about the agenda of today's session. First, we'll talk about the basic introduction, what is predictive analytics and all that. Then we'll talk about AI, right? And third is we'll talk about the AI use cases that map to the predictive analytics part. Then the core predictive analytics, then banking use cases, and significance of the study. First and foremost is how did data science come into picture? Now, AI is not a new thing. AI was there like 30 years back as well. But the way people perceived artificial intelligence was very different. What people thought of is, why don't I create a robot which can go ahead and clean my home, right? So you must have seen a lot of old, TV serials which were, broadcasted in US, which had these concepts of robots and all those things. Now, the way AI has evolved is totally different. Initially, what people thought of is, why don't I go ahead and create a mechanism which will automatically solve a lot of my problems, like automate my problems. Let's say, for example, that I have an Excel sheet, and from that Excel sheet, I need to copy an entry and paste it somewhere else. Now, this has to be done manually. Now, what people have done is they have created certain programs which can automatically copy the data and place it somewhere else. Now, 30 years back, people used to think that this is artificial intelligence, but no, this is robotic process automation. Now, what is AI? As I said, that identifying something automatically without having a very high prior knowledge. I'll give an example. Let's say there's a small kid, right? A newborn kid, but who is continuously seeing, let's say, for example, an apple getting, right? A newborn kid is seeing. And now the kid is around 1 year old. Every day he's seeing a new apple. After 1 year, when let's say, for example, and the parent is continuously showcasing, saying that, okay, see, this is an apple, like that. And it's a red apple. Now the kid automatically identifies after a year or a year and a half that this is an apple, right? I'm just giving a hypothetical example, right? Now the point is, let's say you show a green apple to that kid. Do you think the kid will be able to identify? I guess no. Why? Because what is the prominent thing that the kid must have thought of? The kid must have thought of something like, red color and this shape and size is an apple. Now suddenly you come up with the same shape and size, but the color is green. You really don't know whether the kid doesn't know whether it's an apple or, but he will have some time, or she will have some time that it looks like an apple, but the color is different. Now, automatic all of that comes under machine learning. And when your machine learning methods are not able to solve these kind of problems. What is this problem? You are trying to classify a food as an apple, right? Now, when it becomes more complex, like it is very difficult to identify, but you still have to find patterns to identify something, then this comes under deep learning. Now, the amalgamation of concept of AI, machine learning, deep learning, everything comes into data science domain, right? Now, what are the different use cases of artificial intelligence? This is a very interesting use set of use cases. Obviously, it's slightly out of banking. One part is banking, but others are also very useful for your understanding. First, let's go with something called as email filter. Now, everybody here might be using Gmail, right? And whenever the mail comes to you, either it will go into your inbox or it will go into spam. Now, how does the system identify that this is a spam? So, Google has a mechanism to identify that. So, whenever an email comes to you, it will identify the subject, it will identify the entire body of your email, and it will check if does this look like a spam? Does this look like an email that has been sent to thousands of people? Now, identifying that from the text is not a very easy task. So you use something called as machine learning to solve that problem. Second is automotive. So if you take an example, everybody knows Tesla, right? Now Tesla has this, driverless car. Now, do you think the driverless car is very easy? It's not. Imagine you have so many different variables that are changing across time when you're driving your car, and you require cameras at every angle. Now, it's not that easy. So imagine the total number of variables in the system has to identify whether it has to take a left or it has to take a right, it has to slow down, right? It has to accelerate. Everything has to happen in milliseconds because life is at stake. Now, this is the most complex problem that people are trying to solve in AI, which uses computer vision. Next is healthcare. I'll give you an example. There are a lot of use cases in healthcare. The best use case is building a vaccine. Now, everyone knows about COVID-19, right? It started in the month of December 2019, or I think November 2019. And slow and steady, it's been a year that we are in. But do you really think the vaccine can be created so fast without using AI? It's simply not possible. Now, how AI helps here is your vaccine obviously will have some base. Now, using AI and machine learning techniques, your base will automatically identify whether it will map for various cold related symptoms or not, how it will handle and all that. Now, previously, what people used to do,
Hello, sir.
people used to manually identify all of that. Yeah, I'm audible?
So your voice is breaking, sir, in between, and there is some disturbance in background.
Now, is it clear? Hello, now is it clear?
It's better, but we can still hear some disturbance in background.
Oh, I have to check that. So let me know if it is clear now. Hello, I'm audible?
Yes, sir.
Yes, sir, you're
Yeah. So So typically what happens in healthcare is we use AI and machine learning to solve various problems. Like say for example that you want to identify, so there are a lot of smart watches these days, right, that you have seen, which automatically identifies your oxygen level. It automatically identifies a lot of other things, right? Like say for example your blood pressure and everything. Now, how does it work, right? How does the approximation work? How does it typically understand that what is your blood pressure, what is your systolic, diastolic, all that? Now, all of that typically uses machine learning. So I will not go in depth of that, but this is how it works. Next is banking. Now, whenever, let's say for example, you put 1 rupee in your savings account, where does it go? It typically goes to assets and non-profitable assets. Right? Now, when you put a fixed deposit, you put it for say 1 week, 2 weeks, 1 year, 5 years, 10 years. Now, where does the money go? The bank is going to put that money somewhere else and earn some revenue out of it, right? And give you the interest whatever you are applying. Now, when it is investing, imagine that it's investing in the stock market. When it's investing in the stock market, what will happen? You have to identify the forecast. What would be your stock market price in the near future after 6 months, after 1 year, after 4 days, next day. So identifying all of that when it comes is called forecasting. Forecasting is the prime goal of any machine learning system. Next is industries. Now you must be knowing that there are a lot of industries happening.
Hello, am I audible?
Yes, ma'am.
Yes. Good morning, everyone. Sorry, there's some disturbance with the mic at first, so I'll be continuing with the presentation. My warm regards to all the respected authorities present here. I am Chahat Tandon, a final year student of BIET College pursuing computer science engineering. I would like to thank Hemant sir for giving me this tremendous opportunity to share my views with everyone present here today. So let's talk a little about how artificial intelligence has changed our lives. I am pretty sure most of us might be familiar with the term artificial intelligence as it has been a major focus in some of the famous Hollywood movies like The Matrix, The Terminator, Interstellar, etc. Although Hollywood films and science fiction novels portray AI as human like robots taking over the planet, the actual evolution of AI technologies is not even that smart or that frightening. Instead, AI has grown to offer many different benefits across industries like healthcare, retail, manufacturing, banking, and many more. Artificial intelligence is making its way into your bank accounts. As computers get smarter, financial institutes get more consumer databases and historical transactions with the goal of predicting the future. Predictive analytics can help minimize costs and even improve your experience with your bank. Your smartphone, your house, your car, and your bank all use artificial intelligence on a daily basis. Sometimes it's easy to understand when you ask Siri, Cortana, or OK Google to get you directions. Sometimes it's less obvious, like when you make an abnormal purchase on your credit card and don't get a fraud alert from your bank. AI, ML, and DL are everywhere, and data science is the interdisciplinary field of methods to extract the knowledge needed. All these technologies are making a huge difference in our lives every day and evolving fast by a magnitude of people working to improve them consistently. So, what is predictive analytics? Predictive analytics is the process of using computer models to predict future events. Sophisticated programs rely on artificial intelligence, data mining, and machine learning to analyze enormous amounts of information. With those resources, the model attempts to determine what is likely to happen next, given the current situations and conditions. The term predictive doesn't mean the model always predicts the future accurately. Instead, it means that they deliver their best prediction based on the available information. There are two types of predictive models: classification models and regression models. Various sources and include various types of informations, including spending patterns usually over the course of weeks or months, channel usage, or how the customer is accessing their bank information, such as on mobile, desktop, or at an ATM. Interactions such as representatives, visits, customer is all including the likelihood to request loans, which might be discovered by using another machine learning model. Social media data, such as liking multiple products on Facebook and posting about wanting or needing different products, is also a way of customer retention. Usually, banks looking to adopt this type of software have large stores of big data of most of these types. Enterprise banks often have vast quantities of data that they aren't always sure how to use, even if they want to. And it can be challenging for them to garner insights from this data. Predictive analytics could help with this situation. Much of a customer's spending history, credit history, bank interactions such as transferring money from one account to another, and customer lifetime value will already be labeled. Much of the customer spending history can be seen from their credit scores. An AI application that mines social media data would necessarily involve NLP, that is, natural language processing. Banks could use NLP-based sentiment analysis software to determine a customer's emotional response to a product in a social media post. A bank could use this customer data to determine the best services and products to offer to their customers via mobile banking applications or email promotions. Credit scoring. You may already be familiar with predictive analytics. Credit scoring models use data to predict your credit worthiness. For example, the credit score uses statistical analysis to predict your behavior, such as how likely you are to miss payments. Your score is based in part on how borrowers similar to you have performed in the past. Helping with the budgeting. Computer models can help you manage your finances. They can identify your income and expenses typically hitting your account at every month, and then they can see where your money result. They may be able to present and prevent your problems according to your finances. For example, your mortgage payment hits your account on 15th of every month, but you are running low on cash. Your bank account can send you an alert about that. Fraud prevention and loan approval. Banking fraud is on the rise. A recent survey by Capgemini shows that at a global level, over 60% of the respondents experienced an increase in fraud. The most common banking fraud typologies include scams, phishing, and data theft through social engineering. Predictive analytics can help identify potential fraud by analyzing the most common operational patterns regarding trades, purchases, and payments. This works with both structured data, that is transactions, and unstructured data, that is emails, reviews, forum entries, etc., to uncover hidden patterns. Some banks have monitoring systems in place that can scan data continuously. Other systems are triggered by specific or the results of sampling analysis. Planning personal finances. Machine learning is great at plan learning patterns without making any changes in them. As a person follow a regular pattern, a predictive analytical model could help clients to identify main spending categories, primary money resources, and predict the cash flow trends. Such a model could the user if they are running low on cash or send reminders to avoid late payments and fees. If authorized by the clients, the system could automatically make transfers between different accounts when necessary. This approach could also segmentation. For example, those who are running low on before the break could be offered extensions or express loans at better rates that it is owned. At the same time, Clients with a consistent track record of regular purchases of items like gadgets or travel packages could benefit from products and discounts explicitly designed for them. What about the loan approval, you might ask? Perhaps the greatest risk to lending organization is that presented by loan applicants who are unprepared to fulfill the long-term obligation of paying off a loan. Banks and other lenders spend a lot of time and energy trying to identify the perfect profit margin for them, for a borrower, so they can make the right decision and avoid costly loan defaults and expenses and resources required to take a legal action. Making the right decision and choosing the perfect customers is a crucial part. To avoid consistent results, the business must have a dependable process for attracting the right clientele and reviewing, approving, and managing loans. Predictive analytics can be a crucial piece of the puzzle in supporting the loan approval process and monitoring and managing loan throughout the life cycle of the contract. Augmented analytics helps the businesses to refine this process using algorithms and analytical techniques so the company can see the big picture and target the right audience. These techniques also help the business to identify common risk factors across multiple variables and anticipate loan defaults and issues long before the customer defaults on the loan. Advanced analytical solutions are perfect for credit unions, banks, insurance businesses, auto and real estate loan processes. When applied to the loan approval process, predictive analytics can improve productivity and optimize resources, and it can decrease loan defaults to help the businesses to capitalize on available funds. You can also avail student loans, home loans, as well as business loans from them. Optimal leveraging predictive analytics in wholesale banking. Many challenges beset wholesale banks today: heavy regulations, evolving customer needs, decreasing profit margins, increasing transaction volumes, massive competitive from both traditional banks and the new non-banking finance companies, increased with high-tech financial crimes and rapid technology tests, just to name a few. Managing these challenges requires timely and deeper insights on the risks, customer relationships, costs, revenues, liquidity positions, and other key parameters. While over the years, wholesale banks' data analysis methods have evolved from basic reporting to descriptive by applications, more investigation is required in this field. To maximize the success of their predictive analytics implementation, wholesale banks should do the following: set clear business goals, understand the data from sources including external data sources such as third-party data, government agencies, social media, etc. Prepare the data by performing comprehensive data pre-processing, develop the predictive model, evaluate it, and then deploy it. Monitor the model's effectiveness. The aforementioned steps should be followed cyclically to ensure effectiveness. Further, banks' predictive analytics endeavor must be well supported and underpinned by a robust enabling ecosystem. Core banking sectors. For banks, predictive analytics can help predict customer demand and product preferences by geography and segments, increase cross-selling opportunities, aid in effective relationship pricing, demand-based pricing models, etc. Better targeted offerings, better productive profitability, and analysis is required. Identification of the next best offer and more can be done by predictive analysis. In commercial deposits, acquiring new customer and retaining existing ones while the account takes over preventive and money laundering is a big step and a great challenge. Predictive analytics can enhance a bank's campaign management quality, help identify a customer's next best action, and enable proactive and real-time anti-fraud triggers and insights. In commercial lending, identifying credit opportunities, minimizing credit losses, and automating paper incentives and manual credit analysis are the key business challenges. Here, predictive analytics can help identify customers' next best action, thus predict deterioration in credit performance. and identifying workflow optimization opportunities. In non-credit services, identifying a customer's needs and improving communications with the customer are the key challenges. Now we can talk about some lack of use, relationship managers' belief, and implementation issues. Lack of use. While retail banks leverage predictive analytics for cross-selling, reducing customer attritions, and acquiring consumers, its use in wholesale banks is very low today. Predictive analytics is not much used in wholesale banking growth. Rather, it is focused on risk aspects, portfolio risk underwriting, analysis, usually at entire customer segment profit. Managers many relationship managers believes they know all their clients' needs and predictive analytics today insights. They rely on the relationship of customers with the machines. Along with the fact that relatively small number of wholesale banks adoption of predictive analytics in today's world. However, the bitter truth is that relationship managers rarely know all their clients as well as they think they do. Implementation issues. Many banks are confused about the best approach for predictive analytics implementation. For example, they are unsure about starting with the MDM system or the customer file. Many banks find implementing predictive analytics a daunting task for one or more of the following reasons: complex and heterogeneous legacy technology architectures, soiled systems and processes, fragmented data spanning multiple databases, budgetary constraints, lack of required skills and expertise, and lack of information funding. How can we overcome these challenges? Automated machine learning can help you and your bank overcome these challenges. Automated machine learning, invented by Data Robot, solves many of these challenges and makes the others more manageable. With these advancements, it is now possible to get sustainable, more productive applications at your fingertips, and solutions can be brought to the automated machine learning, best model for your particular situation through competitive elimination from an extensive resource library of common models, cutting hundreds or even thousands of hours time required to find the best model for your situation. It ranks the top performing models using one of the several different metrics available so you can evaluate and select from among the models best suited for your particular problem. It provides transparency into each model's use of data, telling you not just which data is most important, but when to deploy it. Explains individual predictions down to specific data features and their values. Provides diagnosis for understanding each model's accuracy using a variety of standard metrics. Provides tools for understanding and making trade-off decisions between speed and accuracy, positive versus negative predicted values, when and where additional models may help, etc. Reduces the cost, difficulty, and risk of deploying models into your productive environment by providing minimal invasive deployment such as code generation, API development, and deployment to Hadoop. Makes it easier to monitor models performing and detect drift of performance as easily as possible. Makes, retain, makes retaining models on new data and redeploying the models into production simple, fast, and at low risk. Summary of the latest researches and trends in today's world. JP Morgan Chase has funded technology and lately introduced a contract intelligence platform termed as COIN, created to analyze financial documents using overview of 30,000 annual using 36,000 From the initial implementation of learning technology, the same amount could be retrieved in seconds as is added implement this power. Meanwhile, emojis help drive these organizational structures. Wells Fargo's led the establishment of a new intelligence solution team of this year. Steve Ellis, EVP and head of the company's innovation group, was appointed to lead the new team. The AI group is nestled under the umbrella of payments, virtual solutions, and innovation groups. The company began piloting on AI-driven chatbots through the Facebook Messenger platform with several hundred employees. This virtual representative communicates that users to provide account information and help consumers reset their passwords. JP Morgan provide detailed detailed cash forecasting services. Bank of America leveraged big data analytics capabilities to ascertain the reason for many of its purposes. Smaller banks, commercial customers detecting frauds, etc. Based upon the analytics insights, the banks realized that its end-to-end implementation is very useful, for the cash management portal was too rigid and not user-friendly at all. This helped the bank to launch a more flexible online product, Cash Pro Online, and a mobile version as well called Cash Pro Mobile, in the lieu of the earliest product, providing all-in-one offerings. Predictive analytics works by looking for patterns in everything and ruling out the outliers as problems. While in the most cases this could be a safe and sound approach, it could be highly detrimental in specific cases. It can contribute to making the rich richer and the poor poorer by not granting access to financing instruments for risk hedging reasons. That's why companies looking to implement predictive analytics need to pay extra attention to the quality of data fed into their predictive models and follow regulatory guidance to avoid compliance issues. Thank you. If you have any questions, please proceed with that.
Thank you, sir, Hemant and Chahat Tandon, for an excellent session and for the overall. Thank you, sir, and Chahat. To continue the session, I request Assistant Professor Mahesh Arjun to kindly take over the question and answer session.
Thank you, ma'am Lizia. I would request the resource person to kindly elaborate on algorithm-based marketing concept, which is the evolving trend in predictive banking.
Sure. So now I'm audible clearly?
Yes, sir.
Yeah. So basically, there is a concept called algorithmic trading. What it tries to do is, let's say, for example, that you want to buy a share of Reliance Industries Limited, right? And let's say the share price is like 300 or 400 rupees. Now, what will happen using these algorithms is it will identify what was the share price in the past 3 years, particular time range. Let's say you are trying to buy a share in the month of July, right? So every year in the past 6 years or 7 years, what was the price of the share at that time? And what are the relevant factors? Because every share price is not only based on numbers, but is also based on the behavior of people, right? So it will try and identify all of those and forecast in near future that what would be the share price. So there are a lot of algorithms, right? If I name the algorithms, there is something called as time series modeling or time series algorithms. Few of the algorithm names are autoregressive moving average, you have neural net, you have Aremax. So there are a lot of algorithms which will take into consideration the time and also what was the various other factors that are involved. So basis that you can identify this. Hope I answered your question.
Yes, sir, indeed. Thank you so much. The next question, sir, we have in the chat box, which says that what will be the approximate cost for implementing artificial intelligence in a bank?
So typically in a bank, let's take a bank, like a State Bank of India, right, which has maximum number of account holders, lot of NPAs, assets, and everything. Now, to implement a AI-based method, you cannot actually consider it as a whole, but you can take one problem. Let's say that you want to identify fraud in banking. Now, to implement fraud in banking, your cost, most of the cost revolves around the infrastructure, the place or the database where you're storing all of these details and everything, all of that. So typically what I've seen is for implementing an AI project in banking for fraud analytics, typically would cost around 4.5 to 5 lakh rupees for infrastructure and 5 more lakhs for the actual implementation, where you are taking into consideration a 3-month project and 4 people are working on it. So that total cost would be around 10 to 11 lakhs.
Yes, thank you, sir. So the next question we have in the chat box, I'll just brief it up. The question says, how artificial intelligence will deal with sanctioning loans and analyzing credit worthiness of the customer? Because in these two aspects, we require human element which is involved. So how would this human element be replaced by artificial intelligence?
Right. Very good question. The most important point is there is very less chance that it can be 100% AI. There is obviously some human effort involved, but the point is there is a lot of machine learning algorithms or models which will identify whether you should be given loan or not, what is your credit scoring and all those. So there are a lot of variables that come into existence, like say for example, how old are you, uh, did you have any credit default previously, what is the highest credit limit that you are having, right? Have you taken any other loan? So all of those things can amalgamate learning algorithm. Currently it's not, but there's a probably given a low existing work that we have. So the human effort is involved. Did I answer your question?
Yes, sir. Thank you so much. So we'll take the last question which has come in the chat box. It says that how can the artificial intelligence be implemented on modular basis so that if there are any future modifications that can be easily, it will be very easy to upgrade these modifications in the banks. So how do you see it?
It's also a very, very brilliant question. So we have something called as feedback mechanism whenever we implement AI or machine learning models. So what exactly happens is it is really in a very modular structured way. And we obviously have written a lot of comments in between so that we know, and we create a version control document where we know that, okay, this is the point or this is the function that is used for doing XYZ activity, right? So we can modify as and when required, and we can also retrain the model. So sometimes what happens is your model does not perform really well on some unknown data set. So, or unknown data that really comes, right? Something, let's say, for example, there was a demonetization, right? That time there might have been lot of machine learning algorithms which are predicting what would be the profits and all. And suddenly because of this thing, everything will go haywire, right? So there are a lot of methods in which you can basically go ahead and replace your without hindering your entire infrastructure as well as your code architecture.
Thank you, sir.
Hope I was clear on that.
Yes, sir.
Thank you, Mayuresh. I now request Ms. Sanchia Patricia da Costa, student of FIBBA Financial Services, to kindly propose the vote of thanks.
Good afternoon, one and all. It is my pleasure to propose a vote of thanks to all who have witnessed and contributed to the happening of this webinar, a memorable and successful one. I am Ms. Sanchia Patricia da Costa, student of FYBBA Financial Service. Extend a very heartily gratitude to the Honorable Resource Person for the national webinar, Mr. Hemant Palivela, Head of Artificial Intelligence and Machine Learning at eClerk Service Limited at VVM Sri Damodar College of Commerce and Economics, Margam, Goa. I am confident that the participants would have certainly benefited with his resourceful words. Thank you very much, sir, for your invaluable time and glimpse of expertise. I appreciate the overwhelming participation and wholeheartedly thank all the participants for their active participation in the webinar. I take this opportunity to thank the proactive management of our college for inspiring, assisting, and motivating us to always seek productive opportunities. I wish to express my sincere gratitude to Professor Dr. Preeta Dimalia, Principal of our college, for being a constant source of inspiration, encouragement, and support. I sincerely thank the Vice Principal of our college, Dr. Rodney De Silva, for his overwhelming support and motivation in the conduct of this webinar. I must mention a deep sense of appreciation to Ms. Vanessa DeCosta, Ms. Mavia Andre, Ms. Pradnya Natkadni, and Mr. Asen Dias, lab instructors, and Mr. Punarva Prabhu Desai, System Administration for technical expertise and assistance. Event like this cannot happen overnight. It requires planning and bird eye for details. We have been fortunate enough to be backed up by a team of very motivated and dedicated faculty who are result-oriented. I take this opportunity to thank all my teachers for their constant support and motivation. Last but not the least, I thank Assistant Professor Ms. Lysia Gomes, the comparer of the webinar. Once again, I sincerely thank you all. Thank you and have a nice day.
Thank you, Sanchia. Dear participants, shared in the chat box, requesting all to kindly fill the feedback form for receiving system-generated e-certificate on your registered email ID.